ABCD is a parallelogram. ABP and QDC are straight lines. Angle ADP equals angle CBQ, and that equals 90 degrees. And we have to prove that angle ADP is congruent to angle CBQ, and also explain why AQ is parallel to PC. So we're going to start with the congruency part of the proof, and this is what we have to prove. So the ADP, this is the triangle ADP, and that is congruent to triangle QBC or CBQ. So we start with AB is parallel to CD. Now that's already given to us, AB parallel to CD, because ABCD is a parallelogram. And also, yeah, AB is equal to CD, isn't it? Because it's a parallelogram. The next thing is, yep, ABCD parallelogram. I've written it down. And then we look at these two triangles specifically now and see how we can prove them. So what we do is, now angle ADP equals 90 degrees, that's given, equals angle CBQ. So 90 degree means one part is done, congruency part. We'll try and see if it is an AAS or SAS congruency. Right, so and next we have AD equals BC. So this is my AD, and that equals BC because they are the sides of a parallelogram ABCD. And next we have, yep, that's written down, and then we see that angle PAD equals angle QCB, because ABCD is a parallelogram and we have the opposite angles are equal. So if I say this is the opposite angle, they are equal. So this is a parallelogram, and so PAD equals QCB. So two angles and one side equal. So that's good enough to say that our congruency is done. And what that means is triangle ADP is congruent to triangle CBQ, and by angle side AAS congruency. So the first part is done. Now we move on to the next part. So that's, we have to explain that AQ is parallel to PC. Now the way I thought it could be done is if we could prove that APCQ is a parallelogram, then very obviously AQ would be parallel to PC. So how do we go about doing that? We will first consider the two triangles AQD. So little different triangles. So this is one AQD and CBP. So if you consider these two triangles and you see AD is BC, that's already done, AD is BC, because ABCD is a parallelogram, and then QD equals BP. So this is QD, this bit equals BP. Now the reason is we already know that AP equals QC or CQ. That's already done, and we know that ABCD is a parallelogram. So if you subtract AP minus AB, you would get BP. So I've written it a bit differently. I wrote, okay, QC equals AP and the triangles are equal, and then then QD plus BC, QD plus DCS equals AC and AB. Yeah, okay, so that's done. So then, and also angle ADQ equals angle CBP. So ADQ is this angle, and that equals angle CBP. Now you see the reason I think is quite obvious, because ABCD was a parallelogram, and this whole angle, that is angle ADC, equals angle ABC. So angle QDA would be 180 minus angle ADC, and that would be, if you look at the angle PBC, you will see that's also equal to 180 minus angle ABC. And since these two angles are equal, so therefore ADQ would equal CBP. I think. And that's my explanation I've put in there. Okay, and then, so that means two sides including angle, so that's two sides, so we've now got AD and including angle. That's done, right? So this was the including angle that we proved, equal, and two sides and including angle. And so triangle AQD is congruent to triangle CBP. So these bits, this is done, it's congruent. Now what that means is AQ equals BC, and I think you know the rest. Once that's done, then triangle AQD equals, not triangle, sorry, angle AQD equals angle CPB, and these two are the opposite angles of a parallelogram. Their opposite angles are equal, so ABCQ is a parallelogram, and what that means is AQ is parallel to BC, and I think that explains it. If you have any other much simpler proof, please go ahead. But this is my explanation.